Hello, my name is Arisa Thangpaibool. Student number 63107502127, and I'm presenting the topic about serial communication. Communication itself means to exchange sequences of bytes between two devices. As for serial communication is a type of communication using single line to transfer data at a time. Imagine if you want to send your phone number to the receiver, it will require 10 clock cycles to deliver all the full package. And there is another type of communication which is parallel communication. It required at least 8 lines of wires to transfer 1 byte at a time, and only 1 clock cycle to done the job. This is 10 times faster than the series one, but it would be very messy to connect so many wires to send only 1 byte. Therefore, serial communication is widely used to make things easier, and there is many ways to communicate from each device to another, like using USB or known as Universal Serial Bus, which is one of the protocol we can use to communicate. I will introduce you to the communication system, which can divide into 2 types. The first one is synchronous. As the communication need to be synced together, those 2 devices need to have the same timing and protocols. The synchronous system will use clock signal to sync the transmission between those 2 devices, while asynchronous system don't have clock signal, but they will make an agreement beforehand to match the timing, which I will explain later. Serial communication have so many protocol like serial peripheral interface or SPI, inter-integrated circuit or I2C, and TTL serial using USART, which is the one we will focus on because it is very common and the easiest way. This is inside USART chip, which built in the microcontroller. USART stand for Universal Synchronous Asynchronous Receiver Transmitter, which used to transmit or receive data within the microcontroller. It allows us to take data in parallel form and then convert it into serial transmission and transform it back into parallel. This is also called TTL or transistor logic. So as we can see, transmitter have 2 pins of receiver and transmitter. The receiver here will connect to the transmitter of the receiver, and the transmitter here will connect to the receiver of the receiver. And here is how they communicate each other. This is TTL serial communication, and this is how they send the word from each device to another. This here is the starting bit, which will always be 0, and this is the data they will send, which might be 5 to 9 bits. And here is a stop bit, which will always be 1 until it starts again to be 0. As you can see here, bit time is equal to 1 over baud rate. And in general, baud rate would always be 9600. Here's an example of how the receiver receives the text from the transmitter. Here I will send the capital letter of S as an ASCII code. Here 53. In binary it would be 01010011. The signal will send the least significant bit first. Let's see what happened first. You can see the line is in the middle of the bit because the receiver will read the data in the middle of the bit to make sure that it receives the true measurement of the signal, since the beginning of the bit and the end of the bit might be unstable. And here is the starting bit, here 0, and then it reads the data frame here 11001010, and then it stopped at 1 and the message is sent. When an AVR microcontroller sends or receives data using asynchronous communication, the user chip inside is used. I would call these two blocks as a transmit unit. And the transmitted data will be stored in I/O register, then sent to shift register out to pin TX. And I'll call this one as a receive unit, which receive data will be stored in receiving shift register and then stored in I/O register here. But first here, this is clock control and status unit, which will contain flags and status of sending and receiving data. These are some register that you might need to know. First, in RxCO, in UCSROA, is a flag that shows the status of if you receive the data in receive buffer or not. And the next one is UDRE0, which is the status of if it's ready to transmit or not. RxEN0 is work like a switch of the receiver, and TXEN0 it's just like a switch for users transmitter. Both two will be on when it's equal to 1 and off when it's equal to 0. The next one is UBR0 register, which will set up baud rate, which generally be 9600, but when it enters into UBRR, it should be decimal value, which is 103. Next one is UDR0 register. It transmits and receives data in the same register. Here is the model of it. Like it can store, it receives the data here at RxB, and then it transmit out here, but here this block is the same register. As you know, most of the code, I think we can do this example together. First, this line is to open the user transmitter. The second line is to set UCSR0C to 06. This is to indicate asynchronous mode with 8-bit data frame, no parity, and one stop bit. Now this one, as I mentioned before, this is baud rate. As the setup was done, we can go into the loop. This is the monitor setup. The criteria was if the UDRE0 flag was 1 in UCSR0A register, it will show letter G in UDR0 and with a delay of 2 seconds, and just go on and on like that. So the output will be that it will show letter G every 2 seconds of time delay. I hope you enjoyed my presentation. Thank you.